I'm in this book, The Nature Company Guides, Rocks and Fossils. It's a pretty good book, full of a whole hell of a lot of information. Obsidian, gastropods, insects, brachioles, corals, deserts, crossbeds, folded rocks, pillow, basalt and basalt flows, columnar joining, a whole bunch of stuff, a lot of things, a lot of explanations in here. Different types of crystals, how they form, what their hardness is. This is very fascinating stuff. I'm enthralled to be reading this stuff. I love reading stuff like this. But as I go through it, I can't help but to notice how I put this. The Earth is huge. It's a three-dimensional structure. All of geology, for the most part, only focuses on the very thin little crust on the surface. To think, if you're going to examine something, as a scientist would, don't you think you should examine the entire three-dimensional structure, not just the surface? I mean, granted, yeah, there are very deep ocean trenches, and there are very tall mountains, but still, that's only like, compared to the actual thickness of the Earth. And I was like, well, how do they have the Earth forming itself? How did this giant ball come to be? Why is it differentiated? Why is there iron core that's twice the radius of, I mean, you have Texas, which is, the radius of the core is twice the diameter of Texas. So the core is not only 2D structure as in Texas on a map, but that it's all the way through. That's an unbelievably large structure. And to think that these geologists, they completely ignore it because it's not on the surface, I don't think that's good science at all. And I see the assumption here on page 34. The dynamic Earth. Now, I'm in communication classes in college, and what people have to be aware of is there's things you tell people, and there are things that are unspoken that you don't tell them. And more often than not, you can get a lot more information from somebody by what they do not tell you. Because for various reasons, such as maybe they don't know. I mean, sure, it's not good to assume things, but when you read books like this, what they don't cover and what they don't say is a good sign that they don't actually know what they're talking about. It says here, although the Earth appears to be solid, it has evolved during the 4,600 million years of its life, 4.6 billion years, apparently. From a totally molten planet to one with a rigid skin. Today we know the outer skin or crust as either continents or ocean floor. Originally, the whole Earth was comprised of magma without a surface crust. Gravity separated the magma, bringing the lighter elements, mostly silica, to the surface, where being too buoyant to sink, they collected and cooled into a floating rock scum. With further cooling, the surface material solidified to form the earlier continents, and exposed molten magma between the continents also solidified into a thin skin of basalt, the most common rock to solidify from magma. The situation is still apparent today. The light continents rise higher than the more dense basalt. But they're forgetting something very important here. They're completely skipping over it. They say here, although the Earth appears to be solid, it has evolved during the 4.6 billion years of its evolution, or of its life, from a totally molten planet to one with a rigid skin. From a molten planet to one with a rigid skin. They think that's the entire evolution of the Earth. But a geologist is quite myopic. Sure, they're looking at the Earth. What about the objects in outer space that are mostly gaseous? What's going to happen to those? What's going to happen to the ones that are very hot and plasmatic, that are even more energetic than the gaseous ones? A geologist's job isn't to look at the stars. Their job is to look at the Earth. But in order to understand how the Earth works, you have to look at the stars. You have to look outside of the Earth. After all, the Earth is floating in outer space. It's not something that's different than the other things in outer space. Why would it be different? What it is something that's evolved to a point to where we are familiar with it every day. It's something we interact with. We get used to it. We think, oh, this thing has been here for the entire evolution of humanity and life itself. But what they forget is that it wasn't always like this. The myopic nature of geologists is brought to the forefront. We have objects out there which are gaseous and plasmatic. So, what happens to a plasmatic object? It cools and becomes gaseous. What happens to a gaseous object? It cools and solidifies. So, what a geologist does is assume, without any examination of the stars, the Earth was always like this, except for the crust just solidified. That is their entire Earth evolution model. Earth was molten and then the crust solidified. It's basically the same thing as saying, oh well, I just poured liquid aluminum onto the ground and then the top of the liquid aluminum solidified. Well, how'd the aluminum get hot? But that's what the geologists do. They don't ask questions where the questions need to be asked, because they think they don't have enough information. But if they would just put their ego on a shelf, go next door to the astronomy department and say, well, we don't know how the Earth got hot. Do you guys have any objects that you've been finding that are really hot? Oh yes, the astronomer will go, yes, we found these stars, these really hot balls of gas and plasma. And the geologist should have gone, ah, I see. Well, maybe Earth was one of those. That's why the Earth was hot. And the astronomer will go, oh wow, that's interesting, because then that means we actually have a complete model of what happens to those really hot things we've been studying. It would be great to have the ability to actually stand on one of them eventually, if it were to cool down enough. And look at that. We're actually standing on one. Go figure. Today is December 22nd, 2015. It's a story that needs to be shared. But, you know, I don't expect experts to be able to share something of this magnitude, because they're trained to be a part of larger groups, and they're trained to take their ego and place it on a pedestal, because they have degrees and positions inside of organizations where they get lots of money. I don't think that's the future. The future is communicating with one another, and we're sharing insight with one another. Later.